So for problem number, whatever problem this is, what is this, 17? We're asked to find the inverse and then graph it. So to find the inverse, we got to do 4 steps. The first one is we're going to take f of x and we're going to plug in a y. So we're going to say y equals 5 plus 3 over 5x. Okay. Next, we're going to solve for x. So I'm going to subtract 5 from both sides. I get y minus 5 is equal to 3 over 5 times x. Going to multiply this by 5. Going to multiply this by 5. These 5's will cancel, and I get 3x is equal to, now I'm going to distribute this 5 through the parentheses, so I get 5y minus 25. Lastly, I'm going to divide by 3, going to divide by 3. Okay. Now, one of the things that I've noticed is they like to leave, because they're linear functions, because this is a linear function, the textbook likes to separate this. So let me separate it now so it doesn't confuse you guys. And I just went over this with a student. If I say 2 plus 3 over 7, isn't that the same as 2 over 7 plus 3 over 7? So we could separate each term in the numerator by the denominator. So what I'm going to do, so my answer matches the one on the assignment. I'm going to say 5y over 3 minus 25 over 3. We got x by itself, so now we're going to swap. Wherever there's a y, I'm going to plug in an x. Wherever there's an x, I'm going to plug in a y. So this becomes 5x all over 3 minus 25 over 3 equals y. Last step, wherever there's a y, I'm going to plug in the f inverse notation. So up here, I'm going to say 5 over 3 times x minus 25 over 3. And so I'm gonna show you guys how to graph this in Desmos, right? So what we would do is we pull up Desmos, and remember to double check this, or to graph them, you just type in the function. So I'm going to say 5 plus 3 divided by 5 times x, boom. And then to make it match the functions, I think on your assignment the function is blue. Then I'm going to graph the inverse, which is this up here, and if I was smart I would have done this in green instead, but that's okay. So then I have 5 divided by 3 times x, and then we say minus 25 divided by 3, and we'll put that one in green. And we'll leave it like that. Now I'm going to take a screenshot of how they actually have that graphed in your textbook. This was a big issue. Was it for this class or another class? I think it was this class. You guys were like, it's not the same. And I was like, yeah, it is. And then you were like, no, I'm looking at the screen. You guys were like freaking out on me, which is fine. I can handle it. I'm tough enough. I just wish you guys were a little nicer to me. Alright, so this is what the answer looks like in your assignment. right? That's what the assignment has it looking like. But if you look at Desmos, you can kind of see it's the same. But now, what I did, and I kind of glossed over it because it was the end of class, if you want to make sure, and you want to be 100% sure, look at the graph they give you and look at the numbers. My y value goes from 6 to -6. My x value goes from 6 to -6. You just scroll in and out until you have 6 to -6. 6 to -6. And so, and I don't talk about that, I guess. I just assume that you guys figure that stuff out, but because it's really more of an Algebra 1 concept. But if I go in here and I know that the graph is from 6 to 6, I don't really explain that to you guys. I just assume you guys know it. That I purposefully go up here when I take my screenshots and I go, you know, oh, that's too far, actually. So I go right here where it's like -6 and -6, and I kind of go from 6 to 6, or 6 to -6 on both of them. Okay? And we'll save this. And then when I paste it in here, it just kind of matches, but I think yesterday I didn't like make it match, and I think that's what threw some of you guys off. And so if you look at my graph compared to that graph, it still looks a little off, but it's not. That's the right graph. And then if you look at all the other graphs, no other graph matches that. But that is it. And so let's label these so we know. And by the way, that's definitely symmetrical about the diagonal. So if I were to graph the diagonal, why won't it let me write on it? There we go. So that's like y equals x. And you can see they're symmetrical about that, right? This would be f of x here. And then the green one down here, this would be f inverse of x. And this goes on forever this way. And this goes on forever this way. Okay? So that's problem number 17. I'll leave that up there for a second.